processors that I like to use, which are from Atmel, and we've got a few highlights here. They have a whole series, the AVR series of 8-bit microcontrollers, and they go anywhere from, what we would be using would be like an 8-pin DIP package, all the way up to what I have here is a 40-pin DIP package. So you've got a huge range of hardware available for whatever suits your particular need or your particular product. They also have some 32-bit AVR processors, but all of the AVR series isn't the only one that they have. It's just the one that I have experience with. They also have the ARM, and I guess maybe I don't know if they bought the rights for the old 8051 architecture. They also have specialized processors for lots of different things like battery management, and they have an automobiles with the CAN network. The companies, I think they started sometime back in the 80s, but right now, as of fiscal year 2010, they had $1.6 billion in sales, so they're a world player for sure. In the past 2-3 years, more of their sales have been geared towards microprocessors and getting away, and has been a bigger percentage of their sales as opposed to memory and other types of silicon products. And some of their top customers, Alcatel-Lucent, Cisco, and Siemens. On the AVR series, they all have very similar processor cores, so you can start out with, if you're doing some development work and you don't know how many I/O lines that you need, you can start out with one of these bigger processors, get your product working and debugging, and then scale down to something smaller that will fit your needs. And since they all have the same cores, they all have similar registers and use similar programming techniques. Now, some of the smaller processors, they're less likely to have things like specialized silicon for I2C buses to make that simpler, or SPI, things like that. So it's all part of defining what your project is and what you need. And some of the things that really attracted me when I first started looking to the Atmel is the programming is standard ANSI C. So you don't get boxed into some particular IDE. Well, you don't get boxed into some particular programming language that's not very transportable. I know the Arduino, which is getting pretty popular and uses the Atmel chips, they've got their own IDE development. So if you learn an Arduino, then you get kind of tied into their particular language. Or if you want to go to Parallax and use some of their chips, you get tied into Spin or whatever they call it. And to me, I like the idea of something being more flexible and standard. You can use different compilers, you can use different programming environments. I like to use the AVR Studio, but you can write your programs using Programmer's Notepad. So you're not literally roped into anything. And finally, probably the biggest thing was you've got a free integrated a free IDE, a free integrated development environment. They've released recently, I guess probably within the last 6 months, AVR Studio 5. And I've learned on AVR Studio 4.1, which was the most recent at the time. And it's very powerful. You can do everything you need, and if we have time, we'll do a little bit of a demonstration. But I listed it up there twice because it's free, because I just thought that was a pretty smart thing from the people at Atmel to put all this time in development and then give it away, because that's how they draw in new engineers, is to make it easy for people to get started with it. And we'll talk a little bit more about the integrated development environment. I mentioned the two different versions that are out there right now, the AVR Studio 5 and the AVR Studio 4.1. You can do everything that you need using either of those programs. You can write your code. AVR Studio 5 has the built-in compiler. AVR Studio 4.18, it has a separate compiler, but once you get the compiler loaded onto your machine, it integrates completely with AVR Studio 4, and it's seamless. You really don't even see it. You've got good debugging tools. On-chip debugging. You can step through your program one line at a time. You can look at while you're stepping through the program, you can look at program memory, you can look at SRAM, see what's going on in your memory. You can look at your ports. You can look at how your port is configured. Is it configured as an input? Is it configured as an output? You can configure individual pins in your port as an input and an output, and you can see how you can visually see a representation of that as you're going through. You can see what the ports read in. If it's an input port, you can see what's coming in. Another good thing is setting up the breakpoints. Some parts of your program, let's say you connect an LCD and you're using your LCD as part of your debugging process. Well, if you're stepping through line by line, at least my LCD coding, when you get to the point where you're sending something to the LCD, you don't want to step through that one line at a time. You'll get lost. The software could get hung up. So you set up a breakpoint. You can you don't jump past the line or two lines or whatever. You just go straight to it. It runs in real time as if you weren't even in the debugger at all. So you can jump past some of that stuff and then get back to the point where you need to step through and go one line at a time. And as part of your debugging environment, you can look at different CPU registers in addition to memory. You can see pretty much everything that you need to see when you're debugging. Now, it doesn't. It's not the be-all, end-all of debugging. You still have to be thinking about what you're doing, but it's a good tool and it'll get you through a lot of stuff.
Now, this IDE is the one that Atmel puts out.
Right.
Okay.
Yeah, it's the free versions you can get off of the Atmel site. I went to the Atmel site last night, and they still have they've got the Studio 5, but you could probably go to SourceForge.net and get Studio 4.1, or if you look, I didn't look around, you could probably still get those older versions. I don't know if there's a lot of bugs that still have to be worked out of Studio 5 or not, but you've got the newer version and the older version. Another neat feature that I like about these is you can do a software-only simulation. So you're working on your project, and you don't, for whatever reason, you don't want to load your program onto your chip and go through one line at a time, but you still need to test it out. Let's say you're going through your program, you get to a point where you need to read an input port. Well, it's just grabbing your mouse, move it over that input port, and turning on those lines before you execute that line of code, and then you know how your code is going to respond to the input that you've given it. So you've got software simulation and you've got on-chip debugging. Both of those tools are helpful in debugging your code. Okay, and I've already talked a little bit about AVR Studio version 4.18. I think they've got Service Packs 1 and Service Packs 3 out there. Now, if you go with 4.18, you're going to need to install another piece of software called Whenever. Win AVR. That version up there kind of breaks down as to 2010 0110, and that's probably the latest release that they'll do of Whenever, because they'll be pushing Studio 5 right now.
Is that for Windows or Linux? You don't have Windows.
No.
So that's an alternate to using Studio? Is that what you said on this first
Well,
part?
the Win AVR, you have to use Win AVR and Studio 4.18. You have to have both of those. You have to load and install both of those programs on your computer. However, Studio 5, it includes Win AVR.
There is a Linux stack for pushing the code out there, so you don't get the IDE. There are some Eclipse plugins where you can do the AVR type functionalities. But the AVR Studio is specifically a Windows.
Oh, the WinAVR is the compiler?
Yeah.
Oh, I missed
Yeah.
that part.
Yeah,
I'm
yeah,
sorry.
yeah. You can think of, well, I probably didn't say it. The Win AVR is your compiler, and the Win AVR, if I'm thinking right, also has a lot of the. I guess you could best way to say is the programming libraries that you need to program the Atmel chips. The Studio 5 includes the compiler, so that's all you need is that one program. And I did notice that on the Atmel website, they do have lots of video tutorials on Studio 5.
It's a good book for AVR because I know most of them are on source like German.
I haven't written it yet. The short answer is no.
Yeah.
I haven't been able to find one.
I found one that on the tiny AVR that's really well.
Yeah, there's. I wish there was, but there's not. I did get started on one. I don't really recommend it, especially for beginners. But a guy named I caught his Smiley Micro. I don't know if you've heard of him. He has a book, but I got his book like 2 years ago, and it was old and outdated then. And I don't know if he's updated it. You have to use the software that he provides, and it's an older version of Win AVR and the older version of Studio, and you can't use, at least at the time when I got it, you couldn't use the most up-to-date stuff. So you were really roped into the environment that he provided.
Don't buy the book. He has the magazine.
Oh yeah, yeah, yeah. I don't. I mean, I got started and I learned a lot and it helped me. But you know, I'm an electrical engineer, so but for someone who's not, they would probably struggle with his book. So unfortunately, there's not a good. I don't know of a good book where you can learn the C programming and the AVR.
There are a lot of good books in Asia, but they're written in Korean and stuff like that.
Yeah. In spite of the fact that you don't have a good book, there's a website called avrfreaks.net. I live and die by that website. If you're interested in programming Atmel if you're interested in using the Atmel chips at all, that website is going to be your central source for information and help. The forums, they have over a dozen different forums. They have forums for AVR Studio 5. They have a forum for AVR Studio 4.18. They have Studio just for the general AVR series. There's a forum for the X Mega series. They've got a forum for GCC, the compiler. So whatever you've got, there's probably a forum for it.
Probably Arduino too, because I
Yeah.
really hate the IDE of Arduino. There's none of those breakpoints, no line stepping, nothing like that.
Yeah. I don't know if there's an Arduino forum there. Because, I mean, the Arduino's kind of like most of the stuff that you're going to see there, I don't know. I shouldn't say. You could probably find some Arduino stuff there as well.
There's a subforum of guys who take an Arduino and basically strip the bootloader out and we use it as raw AML.
Okay.
Use the boards. And,
But if you're going to do that,
well,
Yeah.
Why-
I think other than buying a board that's already got power supply and already has,
yeah,
You know, to do the board level parts, I guess.
yeah, and taking advantage of some of the shields that are already there. But again, they say they're really throwing away the bootloader and all the drivers and going raw.
yeah, then you got some easy hardware to deal with. That AVRfreaks.net, they have a tutorial forum, and in lack of a good book, they have lots of tons of lessons. Some of them are better than others. There's lessons on pulse width modulation, interfacing with an LCD, USART programming with interrupts, USART programming without interrupts. So basically, if you want to start working with the Atmel chips and the AVR series in particular, depending on your background, you'll probably find a tutorial that's going to cover just about anything that you need to start working with. Additionally, if you need help working on a project, that's what these forums are basically about. You can go and post to the forum and ask questions, and there's a huge amount of activity on this website. So you post something on the forum, somebody, if it's not a forum moderator, it may be just someone that has that same particular interest. Chances are pretty good you will get at least some good answers or some help with whatever it is you're stuck with. So, like I said earlier, that's the central, the kind of like a central repository of knowledge if you want to program with Atmel and the AVRs. Whatever help you need, you are likely to find it there. Another website, of course, is atmel.com, and I've recently started trying to buy products and stuff from sparkfun.com. They have lots of interesting things that you can go and spend your money with them. That's for sure.
When the red box shows up, I'm happy.
Yeah, yeah,
Got a red box from them yesterday.
yeah.
My wife knows that I'll be in the shop for a while.
Okay, here is a screenshot of AVR Studio. This is the one I use, 4.1, and I don't know if my mouse, yes, there it is, yay. All right, this is where, this big screen here in the middle, this is where you do all the programming. And on this program, I work to keep it all just on one page, but of course, if your program gets bigger, you get a slider bar over here, and you can slide up and down. Over here, this represents some of your file structure for your project. And one thing I wish someone would have explained to me that I kind of had to learn the hard way. The name of my program is Presentation. So there it is as part of my file structure. But I've also got one here called LCDC. The compiler comes in here and grabs some of this stuff when it compiles my program. This program right here, LCDC, as well as LCD.H, you don't want to try to have these two programs in a central part of your hard drive and then set up a link to them. You want to have an individual copy of that file in each project, because the linker doesn't work so well, and you may or may not get a good compilation out of it. So you just make these, get in the habit of making any source files or header files, putting them directly in the project, as opposed to having links to them. Down,
If you don't get a good compile, you get errors, or does it just not work?
you will get errors, and that's what I was getting ready to start talking about right here. This area down here is where you get messages about your compilation. It will give you flat out errors and warnings. Warnings, you don't want to ignore them. You want to see what they are and see if it's okay to get them. And the two warnings that I got here, I turned off the optimizer so that I could debug it more easily. And I've got a this line up here, this data array, I set it up for demonstration purposes and I don't use it. So it saw both of those things, and it was part of the warning. So I could just ignore those easily enough.
And what is the optimizer?
The optimizer will go through your code and throw out things that you don't need. And if you're repeating something, it does stuff to it to reduce your code in size. And a good optimizer comes really close to making your C code close to as if you had written it in assembly language. The number I've heard is with AVR Studio is the optimizer can get you about within 10% of what you could do if you had written the C code, the assembly code.
It doesn't restructure what you see in C, it does it after the compile.
Yes.
So you don't see it on you can still step through it line by line as you wrote it?
Exactly.
Okay.
Well, as long as you turn there's some tricks to that. Turning the optimizer off is one of them. And as far as going through your code one line at a time, because if you don't turn your optimizer off, your code could skip around, and you just like, what's going on? It really makes it hard to debug. Another thing that you would want to do to make it easier to step through your code one line at a time, and I've done it on all of these, is make these volatile. I kind of know what it does, but I don't understand it enough to talk about it and make any sense. But understand that if you want to step through your code one line at a time, you need to make all of your variables volatile. Once you get it working, you can go back and take that out. You can turn your optimizer back on and then download that to your processor, the optimized code.
Not necessarily. Volatile tripped me up back when I first started doing AVR. Didn't know volatile existed. I like to have an interrupt routine where one of the timers calls the interrupt routine like 10,000 times a second, and then do a few things in the interrupt routine like make more timers. Like have a variable that counts down so that the main code can set this timer variable to say 10, and then the interrupt routine will decrement it until it gets to 0 every 1/10,000th of a second.
Yeah.
Okay. Problem was, it never reached, the main program never saw that variable change.
Right.
Because it changed in the interrupt routine.
But it didn't change.
But it didn't change where I was looking at it. I could make a loop, check variable T, timer, has it gone to 0 yet? No. It'll stay in that loop forever, even though it did in fact decrement to 0 down at the, because the compiler optimized that, said you never change this variable, I can put a constant in there, who cares?
Yeah.
But if you set it as volatile, then it really does look at the actual variable every single time.
Right.
And that fixed that little problem, so you have to remember to put volatile in there if you have anything that changes in an interrupt routine.
Exactly. And in fact, going back to my favorite website, AVR Freaks, there is a really good tutorial that a guy has written that explains what volatile does for you and the optimizer. And that's where I learned what I learned about it, is just reading that article. So when it's not just for debugging anymore. Another part of the screen that we're going to see, this is looking at port D, which is what I've used in the program to read the push button that I've inputted and light the LED that I'm lighting. I split port D in half. One half is input, one half is output. Now, we don't see it all here because it didn't quite make it into the presentation, but port D is an 8-bit port, so we see 1, 2, 3, 3.5. But there are, all 8 of them really are there, and you really can see them, and they really do help you. This first one, this first line here is DDRD. That's Data Direction Register for port D. That's where you can individually assign your pins as inputs or outputs. There's another register called pin D. When you want to read this value in, you have to use the pin function, which is what I've done here in the program. Now this pin And this DDRD and this port stuff, all of that is part of your AVR, your Win AVR compiler. So when you use these commands, pin and port, your compiler will go, because I've included it here, it'll go look for the proper files, understand what those commands do, and generate the hex code accordingly. And when you're writing out, you write out the port D. So I've got it here. Another way here, port D, we're writing out to turn the LED off. Port D, we're writing out to turn it on. And then this window up here lets you decide what you want to look at. Port D, port C, port B, port A. Do you want to look at your EEPROM? Do you want to look at your timer? Do you want to look at your USART? Do you want to look at the TWI bus? So you select one of these here, and then it shows up down here in this window. Unfortunately, whatever you had there before goes away, so you kind of have to balance what you want to look at the time. That's your basic interface. That's what you're going to be looking at and debugging out of most of the time. One other important thing you need to know about using AVR, you've got this window here where you can set some of your parameters. You come over here to this part of the screen, you right click in the white area, this window pops up. You've already told it what processor you're going to use when you set it up. Here's how you change the optimizer. Let's see, I've got it for 0.0, which is optimizing off. And I always like to have a frequency crystal on my chip, so that's where you enter that as well. If you don't use a frequency, if you don't use a crystal, the default clock rate for your AVRs is 1 megahertz. And if your timing's not critical, then you don't need it. But if you're going to communicate with another chip, then obviously your timing is critical. Now this is a screen that we've used from going through and doing the debugging. Right here, this little white arrow, that shows you the current line that you're looking at. You step through this one line at a time. There's a key up here, or you just use the F11 key. If you want to see what happens from this command, everything happens kind of after the fact. So if you want to see what happens after you do the DDR equals hex F0, well, you got to step past that. This is where your yellow arrow is. That's the next line to be executed. So you'll step past this, and then you can come down here and look at your D registers. And this line right here, so you can see where I've configured the register. The first, the high nibble, or the top half of the byte, is set for outputs. The bottom half is set for inputs. Right here, we're looking at memory. And you can change this from data memory to program memory. This line up here, where I set up this data array, hex 31, 32, all the way up to 35, you can come down here to the memory, and if you hold the cursor over the data array, it will tell you the address. But so you can come down here and look, 32, 33, 34, 35, and then it shows you the ASCII characters out here. So that's just a demonstration of how you can see what's going on as you step through. You also have a watch window. One of my variables is input value, and it's at hex 0F, I think, and then count is at 0. And this count variable is here strictly for demonstration purposes. I don't use it at all, and count would have been optimized out if I didn't make it volatile.
So you're when you're port D, you're writing F and then 0, but you're just lighting an LED.
Correct.
So is there a reason? I mean, you just did F because you wanted to just write the whole,
Yeah.
all the pins?
Yeah,
Okay.
I wrote, since I kind of split the port in half is input, half is output, I was just being lazy and wrote F out as
Okay.
opposed to exactly the pin that the LED is connected to.
You set a break on a watch variable. Some IDs will let you do that. So when this variable reaches a certain value, you break at that.
Okay, well, I guess I got to give you your money now,
Oh.
because here's the next slide, and that's what I'm showing.
Okay, cool.
these red dots indicate where you're going to break your program. So several minutes ago I mentioned the LCD stuff. You don't want to step through the LCD initialization or the LCD clear screen. Only bad things can happen then. So on the previous screen, my yellow arrow was right here. And I knew that I didn't want to have to deal with all this stuff. So I came up here, you've got a little red dot there. You can set a breakpoint. And when you're here, you come up to, I think it is this one, and it will run until it gets to the break. So you don't skip this, but your processor executes it in real time, and you don't get bogged down trying to step through that. So I jumped to this, and using this little while loop right here, what this circuit does is it waits and waits and waits for me to push the button. And then when it pushes the button, it comes down to this little for loop right here that has the necessary code to blink my LED 5 times, 1 second on, 1 second off, and it also writes the value count out to the LCD, so you can see the LCD displaying that value, and you can look at your LED as well. And I use the LCD a lot for troubleshooting if I want to send a value out to it. The disadvantage is it takes up essentially a whole port, so you've got to have a big chip to do something like that. Additionally, down here on the previous screen, count was 0. Now count is 1 because we've gotten into this loop. And I've got this breakpoint here. I can come up here. Every time it stops there, I can come here, push this button again. It'll go through the loop and stop, go through the loop and stop, go through the loop and stop until you've executed all that code. Once you've gone through the loop 5 times, just like you expect, it comes back here and starts waiting for the next push button. You can come over here and look at what it's reading in on port D, what you're writing out to port D right now. It's reading in all S. I'm not exactly sure why it's doing that, but I mean that's just what it's got. So the main ideas here are you can step through. You can go through one line at a time. You can jump over chunks of code that you know work and you don't want to see, you don't need to see. You can look at what's going on in your memory. You can look at your ports. You've got watch variables down here so you can see what's happening. And then this is the compile window. It kind of gets pushed out of the way when you start your debugging. Up here, you can watch your program counter and then some of your main processor registers, X, Y, and Z, your S register. Now if you had a bigger screen, which I do, I can expand this out and still see all of my other stuff. And that's it.
How do you debug a robot that's running around without the inline connected? Right now you have processor not connected.
Right. And I'm glad, okay.
Yeah, that's part of it.
This right here is called an AVR Dragon. It costs $50. If you're going to program AVRs, get one of these. It's cheap. This is also, like I said, your programmer, but it's also my on-chip debugger. And this is what lets you go through one line at a time. I don't know how much they cost to make, but I've picked up this cable, this ribbon cable here at work, plugged it into the JTAG connector. I've got the JTAG connector set up here as part of my circuit board, but like I said, it takes up a whole port. So the JTAG programmer and debugger is nice. If you don't need this big chip, you can work out your software here and then find other ways to program a smaller chip and work on that. But this is called an AVR Dragon. I got it from Mauser, and Atmel says you can't charge more than $49.99 for it. So this is a good thing. My ability to program and debug got much easier when I bought one of these.
And say it takes up an entire port in order to do that.
Yeah, you have to. Yeah,
Okay.
it doesn't take up all the lines of the port, but I've read that if you try to do other stuff with that particular port and you've got your JTAG enabled, it might not work so well.
Yeah. That's why the Arduinos don't do that debugging, is because they use all the ports for other stuff.
Yeah.
And then they use a bootloader and get programming now, so they don't even let you have access to it.
Yeah.
If you're gonna do that, you just plan to use that port for stuff that's not that important while you're debugging LEDs or whatever. And
Yeah.
so you don't lose much.
Of course, I mean, you don't also have to do it the way I did when you're debugging. But I mean, I need the LCD for part of my project because I'm reading this GPS sensor displaying the data. But using an LCD for debugging, especially if you got the AVR Dragon, is kind of like redundant and maybe even dumb. But if you've got pins and it works, then go ahead and do it. And this little circuit I came up with last night to show in the demonstration. It's pretty simple. It's just sitting here waiting on me to push the button, and then when I push the button, it blinks the LED 5 times and then sends the count variable out to the LCD.
Maybe a 5-second countdown. Robot starting.
There you go.
Except for it blinks it 5 times and second on, second off, maybe 10 seconds.
There you go.
Done that before. Your sumo's on his back before you, oh, wait a minute.
One really nice feature about this is when you're using the JTAG, to program it, you can send the program over here and run it with the push of a button. And if it doesn't do what you want, you've got your program right in front of you. You can go back, and he just said, well, I don't want it to blink on for 1 second and then off for 1 second. I need it to be half a second. So you just go up there, change your code, recompile it, and with the push of one button, and you send it with the push of the next button, and bam, you got your new code on there, and you can watch it and see what it's doing.